Hi dears, welcome to another episode of Blast from the Past through the previous year questions of JEE Advanced. Which one we have today? JEE Advanced 2017, a question from 2017 paper we have today, right? Let's go through. The correct statements. So it is once again more than one choice question. Correct statements for the following addition reactions is or are. So first molecule given, first reaction given, you have trans product CS3 on the opposite side. So you have trans butene. So trans 2-butene undergoing addition with bromine. All of you know bromine addition is it syn addition or anti-addition? Bromination is anti-addition. Bromination is anti-addition. And the product M and N. Second one, you have cis compound. This is cis compound. This compound undergoing again anti-addition. The product O and P. And then followed by choices A, B, C, D. M and O, N and P. Two pair of enantiomers. Bromination proceed through trans addition in both the reactions. Bromination in fact is trans addition. It is anti-addition. Bromination is anti-addition. What is anti-addition? All of you know, but still, this is carbon-carbon double bond, carbon-carbon double bond, and which is polarizing bromine. Bromine polarizes as minus and plus, and this is attacking over here, and you get a bromonium ion. You get a bromonium ion, cyclic bromonium ion. You get like this, cyclic bromonium ion. Isn't it? You know this. And now Br minus released from here. Br minus will be attacking from the other side of the molecule. So one bromine attacked from bottom face, if you assume, the other bromine attacked from the top, like that. So it is anti-addition, trans addition. So second statement is straight away we can understand both are trans addition. Option B is a correct answer. O and P are identical molecules. Let us investigate. M and N and P are two pair of diastereomers. So this is what given statements of which already B found to be perfect, because bromination is anti-addition and option B is correct. What about the other one? Regarding other ones, I think many of you know. Even otherwise, let me tell you how to identify the regio reactions, how to understand the stereochemistry of such a reactions. When you try to investigate the stereochemistry of such a reaction, many of you may be aware of, there are two types of reactant molecules. One is cis and one is trans. And there are two types of reaction, syn addition, anti-addition, syn addition, anti-addition. There are two types of product, racemic and meso. So let me tell you, there are two types of reactants. Number one, cis reactant and trans reactant. So there are two types of reactants, and there are two types of reaction. There is syn addition and there is anti-addition. What is syn addition? Addition happen from the same side is called syn addition, while addition happening one from this, that is anti-addition, as we have seen in this case. One bromine added from bottom, one bromine will be added from top, that is anti-addition. So bromination is anti-addition, while reaction with the Bayer's reagent, all of you know, hydroxylation, that is a syn addition. So there are two types of reaction and there are two types of product. One is racemic and the other is meso. One is racemic and the other is meso. What is racemic? Racemic is equimolar quantity of dextro and levo, isn't it? Equimolar quantity of non-superimposable mirror images to each other. Equimolar quantity of enantiomers are called racemic. Enantiomers, all of you know, the non-superimposable mirror images to each other. And what about meso? Meso means a molecule with the chiral center but does not perform optical activity due to internal compensation, right? So there are two types of reactants. There are two types of reaction and there are two types of products. Two types of reactant, cis and trans. Two types of reaction, syn addition, anti addition. Two types of products, racemic and meso. Now, which reaction, what product is obtained? Which reactant, which reaction, what product is obtained? That is what the stereochemistry, which we have discussed in detail in our classes, and almost all of you may be aware of, but still I am reminding you how it can be determined. It can be easily determined. I will tell you, I have told you, I have given the notes. A very easy way to memorize which reactant undergo what reaction and you get what product. It can be easily remembered by memorizing a very small code. A very small code. Remember, car. It was taught in the classes. Car. By memorizing car, by memorizing the code car, you can memorize which reactant give what reaction and what product. In fact, this one code is equivalent to 4 different codes. Remember only one. Enough. And what is this code referring to? Very simple, very simple. Cis compound undergoing anti-addition, you get a racemic product. Cis compound undergoing anti-addition, you will get racemic product. By memorizing this one code, you can find out any combination of reaction. So, cis anti-racemic, therefore cis syn will be meso. Cis anti will be racemic. Cis syn will be meso. Cis anti will be racemic. Cis syn will be meso. Like that. Then trans anti will be, cis anti is racemic, trans anti will be meso. Trans anti is meso, trans syn will be racemic. So cis anti racemic, cis syn meso, trans anti meso, trans syn racemic. So one code is actually giving you all possible combinations that happens in that stereochemistry involved in the reaction. This was dealt in the classes and detailed examples were discussed in the classes. Now let us review. Now let us review how hope this matter is clear. Cis compound anti-addition racemic. Cis compound syn addition meso. Cis anti-racemic trans anti-meso. Trans anti-meso trans syn racemic. Easy. Right. Now coming back to this, we have trans compound undergoing anti-addition. Trans compound undergoing anti-addition. Cis anti is racemic. Trans anti will be meso. So this product is M and N are meso product. M and N are meso product. What will be the meso product? This molecule undergoing anti-addition. This molecule undergoing anti-addition. We have Br, delta minus delta plus. This is attacked from here and you get a halonium ion. You get a bromonium ion like this, and the next bromine Br minus will be added across here and the final product will be meso product. This is meso product. H, Br, H, Br, CH3, CH3. This is a meso product. Meso product is optically inactive due to internal compensation. In fact, I would say both M and N are same because this and its mirror image are same, as it is optically inactive due to internal compensation. This rotation given by this chiral center will be cancelled by this. There is an internal compensation. The net optical activity of meso compound will be 0. and their mirror image, they are not enantiomers. There are two compounds written M and N. In fact, M and N are same. M and N are one and same as it is non-resolvable. It is not optically active. The net optical activity is 0, and such a molecule will be called a meso. There is a plane of symmetry. You can see the bottom and the top and bottom portion of the molecules are same. You see the top portion and bottom portion are same. Is it clear? So this is M and N. M and N are identical. Do we have such a combination? M and O, N and P, two pair of enantiomers. OP identical molecules. OP. No, it's wrong. OP identical molecules. This we have to investigate. M and N identical. We don't have such a statement. M and N identical. Right? And now, so that's about the first reaction. What about the second reaction? What about the second reaction? We have cis molecule undergoing anti-addition. Cis molecule undergoing anti-addition. There will be again bromination. Br minus and plus attacking here. You get cyclic halonium ion. You get a cyclic halonium ion, cyclic bromonium ion, and now the Br minus attack from the other side. You will get a racemic. You will get a racemic. This is trans compound anti-addition, which is meso, and here we have cis compound anti-addition. We will get a racemic. What is racemic? Racemic will be enantiomeric pair. You get H, Br, H. This is molecule number 1, say O. And you have the mirror image, non-superimposable mirror image, CH3, CH3 like this, Br, H, Br. This is compound P. Hope you understand compound P and O. Compound O and P are enantiomers. Compound O and P are enantiomers and they form racemic mixture. Compound O and P are identical molecules. It is wrong. Option C is wrong. Option A, M and O, N and P are two pair of enantiomers. This and this are not enantiomers. This molecule and this molecule are not enantiomers. O and P are enantiomers. O and P are enantiomers. We don't have such a statement. So statement 1 is wrong, statement C is wrong. What about D? M and O, N and P are two pair of enantiomers. Please understand, M and N are same. M and N are same. Okay. M and O. So this molecule and this molecule. And again this molecule and this molecule. They are diastereomers. That is correct answer. They are diastereomers. That is correct answer. What is meant by diastereomers? Diastereomers, stereoisomers, which are not mirror images to each other. They are stereoisomers. This and this are stereoisomers, but not mirror images. This and this are not mirror images. This and this are not mirror images, but they are stereoisomers. They are called diastereomers. Right? So the correct answer will be second choice, box, and fourth choice, D, where A and C will be wrong comments. And this is related to the specific stereochemical action on cis and trans molecules by syn anti-additions. Here it was anti-addition reaction, bromination reaction across but2ene, cis-butene and trans-butene. Cis-butene undergoing anti-addition, you will get a racemic. This will be racemic product. Racemic product, equimolar mixture of enantiomers. While trans compound undergoing anti-addition, you get a meso. And which all compounds, which all addition, what all combinations are possible, already we have discussed in detail, which already was discussed earlier in classes. So, two types of reactants, substrate molecules, cis and trans, two types of reaction, two types of products, which will give you what discussed here, which will help you to understand variety of such kind of stereochemistry related questions and the predicting various product in such cases. Right? I think it is clear to all. I think it is clear to all. Yes. Cis compound, anti-addition, racemic mixture. If you remember that, CAR. If you remember that, all related stereochemistry, stereochemical products can be predicted easily, right? That's all from the question. We'll meet with another question in another video. Thank you. Bye. See you.